Hi everyone, in this video we're taking a look at question 8b part 2 from the 2000 HSC 4-unit exam. So it's the very last question on that exam. This part 2 naturally follows on from part 1, and if you haven't seen my video on part 1, it's probably worth going and taking a look because this part 2 asks us to use part 1. So you probably want to have an understanding of what was going on there. Part 2 simply asks us to find the value of probability of 2, 3, or in other words, the probability of getting a total of 2 heads being tossed before 3 tails, and we're told use part 1. Alright, so this is what we need to do. Naturally, we should probably go and get part 1. So part 1 told us that the probability of r comma s is equal to a half times the probability of r minus 1 comma s plus a half times the probability of r comma s minus 1. So that's the relationship that we got our head around in part 1. Really, we're just inserting some values here. So we could say, therefore, the probability of 2 comma 3 will be a half times the probability of 2 minus 1 is 1, comma 3, plus a half times the probability of 2, comma 3 minus 1 is 2. And so essentially now we need to work out, well, what's the probability of 1, 3, and what's the probability of 2, 2. It's probably a valid approach to go, well, how about I just keep iterating through this until I get down to a 0 and then get my head around what P0 means, and P0 comma 1 we're told is 1, and you'd probably then need to grapple with what is P02 in this case. But I don't actually think you need to necessarily do that. I think you could and you'd probably get to the right place. But I think the P1 comma 3 and P2 comma 2, those numbers are probably small enough that we can just think of all the possible cases and kind of just almost from first principles work out what these two probabilities are, and then multiply each of them by half and add them up, and we've got our answer. So let's start with P13. So the probability of 1 comma 3 is the probability, I might just use an arrow here to kind of say, well, what we're dealing with here is that we get 1 head before 3 tails. And what are the ways we can do that? Well, if we get a head on the first toss, then we're there, because it almost doesn't matter what happens after that. If you keep flipping the coin, you've definitely got 1 head before 3 tails at least. So that's one way to get 1 head before 3 tails. You just flip a head on the first go. Another way would be we flip a tail on the first go and then we flip a head. In that case, we've got our 1 head before being able to get 3 tails. So that's another way. Another way would be if we got tails and then we got tails and then we got a head. We'd also be satisfying this possibility because, again, we've got a head before getting 3 tails. Now, we can't keep going because if I was to go tails, 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 head, well, then we haven't met the criteria because we got 3 tails before getting 1 head. So these are our 3 possibilities. So as I kind of mentioned, they're not hard to calculate from first principles. So we can just work out P13 in that way. So we can say, therefore, the probability of 1 comma 3 would be the probability of a head, which in a fair coin is just a half, plus the probability of tails times head, or getting a tail and then getting a head, just a half times a half, plus a tail, which is a half, times another tail, which is a half, times a head, which is a half. So really what we're dealing with is a half plus a quarter plus 2 times 2 times 2 is 8, so an 8. So if we try and get all that on a common denominator, that'll be 4 on 8 plus 2 on 8 plus 1 on 8. 4 plus 2 is 6 plus 1 is 7. That's going to be 7 on 8. And now we just want to think about the probability of 2 comma 3. Sorry, 2 comma 2, not 2 comma 3. So we did 1 comma 3, now it's 2 comma 2. So yeah, probably got enough room to keep going. So we could say for the 2 comma 2, what we're saying there is we want 2 heads before we get 2 tails. So like we did before, what are the ways we could do that? Well, we could get a head and then a head. For sure, that will let us get 2 heads before getting 2 tails. Or we could get a head first and then a tail, but then a head to make sure we got our 2 heads before 2 tails. Or we could get a tail first, and we can't then get a tail because then we're done, but we could then get 2 heads. And again, that covers all our possibilities because we can't do tail first and then tail, and we can't do head first and then 2 tails. So these are all the ways that you can get 2 heads before getting 2 tails. So again, we just need to work out those probabilities. So therefore, the probability of 2 comma 2 would be a half times a half plus a head, which is a half times a tail, which is a half times a head, plus a half times a half times a half. And at this point, maybe I should turn over. So let's just continue. So therefore, the probability of 2 comma 2 is equal to, let's just work these out. So it's a quarter plus an eighth plus an eighth. So 1 on 8 plus 1 on 8. And if we just get everything over 8, we'll get 2 on 8 plus 1 on 8 plus 1 on 8. So that's 2, 3, 4 on 8. Or in other words, 1 on 2. 4 goes into 4 once and into 8 2. Yep, so that's a half. So therefore, going back to what we're really trying to work out, which is the probability of 2 comma 3. Probability of 2 comma 3 is equal to a half times the probability of 1 comma 3, which we worked out is 7 on 8, plus a half times the probability of 2 comma 2, which we just worked out is a half. So what's that? That's 7 over 16 plus 1 on 4. Now, if I want to get everything in a common denominator, I'll just put it all on 16. So 7 on 16 plus 4 on 16 would get you to 1 on 4. 7 plus 4 is 11. So we end up with 11 on 16. And I don't think you can simplify that any further. So I think that's the answer, 11 on 16.
Panic boom!
So yeah, that's how you can do that question. I think, I guess in the grand scheme of things, probably some relatively easy marks here, given it's the final question on the 4-unit exam, and ultimately we're just plugging in numbers. You could probably certainly pick up a mark, you'd hope, from working that out. Maybe you could argue that there is a bit of thought, or at least really understanding what's going on to then be able to work out these 2 probabilities. And again, I think you could try and iterate through, but I just suspect maybe you end up down a rabbit hole, I'm not sure, if you then try to keep plugging that back in. Because then you're in the territory of trying to prove what is probability of, say you'd end up with 0, 2. We're told probability of 0, 1, but it'll take a bit of work to then expand on that, whereas I just don't think you have to. I think if you think of all the possible ways you can get each of these, you kind of get there without too much effort. So I think this is probably the simplest way to go for this question. So hopefully it all made sense, and you could follow along with that. So now what I'll do is in the next video, I'll work through part 3. All right, tick boom.